Was very happy, thinking of happy things, when.
Yay, another assignment from Miss Laura.
Me being excited about making a sword. There's a lot of materials in here. The perfect one. 1045 steel, of course. Well, first of all, I'm gonna explain to you a little bit about the basic composition and characteristics of the 1045 steel. 1045 steel is composed of carbon, iron, manganese, sulfur, phosphorus. Yeah, I think that's all. And someplace in here, I'm gonna put some other information about the density, the modulus of elasticity, the ultimate tensile strength. That is very important to know when we are looking for a material to make a sword. And also, I want to talk a little bit about, some characteristics. It has good weldability, good machinability, it has high strength and impact properties, and also some other ones that let's get started. I'm exhausted. Well, basically what I just did was the normalizing process. Before the process, the grain size was larger or bigger, and also the grain's structure is more irregular. And after the process, the grain size, you can see, is much more finer, smaller, and also the grain structure is more uniform, more organized. So yeah, basically that was the normalizing process.
Me, when I realized I didn't add the finishing details. Thinking and thinking.
Which heat treatment would result in coarse perlite that is soft and ductile?
Of course, annealing, because annealing is a process that increases a material's ductility, but at the same time, it softens the material. Yeah, of course. I know a lot of people may get confused between the annealing and the normalizing process because they are kind of similar, but they are different. The difference is how they cool down. For example, in the normalizing process, the material is heated and then is cooled down in another room at room temperature. Of course, the material is exposed to the air of that room. And in the annealing process, the material is heated up, of course. The material is over a surface or a furnace, and then the material cools down over that same surface. That same surface that was heated previously. So the surface and the sword, in this case, they both cool down at the same time. That's why in annealing, we have as a result a larger grain size.
When I found out it is too soft to hold a sharp edge.
What type of heat treatment can I perform to harden your blade and make it more wear resistant?
Quenching and then tempering. Yeah, that's a very good option. Since quenching improves a material's hardness but also makes it more brittle. And with the tempering process, we can solve this problem since tempering increases a material's toughness. Through the whole exhausting and fun process of making the sword, I was able to see the
martensite structure.
Since martensite appears when a material is cooled rapidly, and this is exactly what happens in quenching. But after the tempering process, I was able to see the
tempered martensite,
which was the final result.